This is a video for Math 386 and the topic is derivatives. So for starters, let's take a look at the derivative rules. Now, if f of x is equal to k is constant, the derivative of f of x is 0. The derivative of any constant is 0. Number 2, if f of x equals x, the derivative of f of x is 1. If f of x equals x squared, the derivative of f of x is 2x. Number 4, if f of x equals x to the third, the derivative of f of x is 3x raised to the second power. And you can think of the derivative of x squared as 2x to the first power. And if we can see a pattern, we could say, in general, if f of x equals x to the n, the derivative of f of x is equal to nx raised to the n minus 1. Now, one thing I want you to note is I claim n can be any real number. Okay? We could actually show that. Now, additional rules. Now, we'll call this number 5. If f of x equals e to the x, the derivative of e to the x happens to be e to the x. Number 6, if f of x is equal to sine x, f prime of x is cosine x. And then last one, number 7, if f of x is equal to cosine x, the derivative of f of x is negative sine of x. Okay, let's take a look at some examples. So the directions say to differentiate. The function. Now, what I'm going to do is take a look at example 1. Suppose I'm given g of x equals 4x plus 7. And I want to find the derivative of g of x. So what I'm going to do is I'm going to take the derivative of f of x, and I'm going to take the derivative of, let me say it this way. I'm going to take the derivative of 4x, and I'm going to take the derivative of 7, and then I'm going to add those results. Okay? Now, so g prime of x is 4 multiplied by 1. I'm going to go plus the derivative of 7 is 0. And notice how I called it g prime of x. I'm absolutely going to look for that. So g prime of x is equal to 4. That's example 1. Let's take a look at example 2. Suppose g of t equals 5t plus 4t squared. And I want the derivative of g of t. The derivative of t is 1. So we end up getting 5 times 1, okay? And the derivative of 4t squared is 4 multiplied by 2t. So the correct answer here should be 5 plus 8t. Let's take a look at example 3. Suppose I'm given f of x equals x to the 75 minus x plus 3. And I want the derivative. So I'm going to go 75x to the 74. So I applied the power rule on that first term right here. And then the derivative of x is 1. So I get 75x to the 74 minus 1. And we'll take a look at example 4. So suppose for example 4, I have f of t equals negative 2e to the t. And I want the derivative of f of t. The derivative of e to the t is e to the t. So the derivative of negative 2e to the t is negative 2 times e to the t. So the constant just goes along for the ride. Example 5. On example 5, suppose f of t is t cubed plus e to the third. Now, this is an important example, right? I'm going to put a star by this. Why? Because it's a trap, right? E to the third, right? This number here, that's constant. And if we go back to our rules, what's the derivative of any constant? It's 0. So if I want f prime of t, I'm going to get 3t raised to the second plus 0. And that's equal to 3t squared. That's example 5. Let's take a look at 6. Example 6. Suppose w of v equals 1.8 v to the negative 3. So one thing I want to explain to you about this problem is when we want the derivative, notice how there's a negative exponent in the original function. And so if you have a negative exponent in the derivative, that's fine. So if I'm going to take 1.8 and I'm going to multiply this by negative 3v raised to the negative 4. But 1.8 times negative 3 is negative 5 point, well, I'm old school, so I'm going to take 1.8 and I'm going to multiply by 3. So 3 times 8 is 24. I'm going to write down the 4, carry the 2. And then 3 times 1 plus 2 is 5. And so the correct answer should be 5.4. So this is negative 5.4 v to the negative 4. Now, or if you want to, you can say w prime of v is negative 5.4 over v to the 4th. Either one's okay. And now remember, in the beginning, notice how we have a negative exponent. And so in the answer, if we have a negative exponent, that's acceptable. Okay? So I'm going to put a box around this guy, a rectangle. So that's example 6. Let's take a look at example 7. So in example 7, we have, let's try this one. R of z is z to the negative 5 minus z to the 1/2. And I want r prime of z. So this is negative 5z to the negative 6 minus 1/2 z. And then remember, if I take 1/2 and take 1 away, this is 1/2 minus 2 over 2. And so that's minus 1/2 z to the negative 1/2. And again, that's okay because one of the terms has a negative exponent. So that one is okay. Let's take a look at example 8. So in example 8, we have, suppose f of x equals x squared times x plus 3. Now, we don't know how to deal with products, but what I can do is apply the distributive property. And so from here, I can say f of x is equal to x cubed plus 3x squared. If I take the derivative, I get 3x squared plus 3 times the derivative of x squared, which is 2x. And so this is 3x squared plus 6x. That's example 8. Let's take a look at example 9. We'll do 2 more. So for example 9, we have y equals, I'll do this one, 3x squared plus x cubed divided by x. So when you see something like this, we want to split the fraction. That should be an automatic first step. And so this is 3x plus x squared. Okay. Remember, that x is to the first power. So I want y prime. The derivative of x is 1. And so this is 3 times 1. The derivative of x squared is 2x. And so y prime is 3 plus 2x. And that's how we do that one. Oh, here's a good one. Suppose f of x equals e to the x plus x to the e. Very tricky problem, deceptively, because now we learned that the derivative of e to the x is e to the x. Now remember, e is a number, so we're viewing this x to the e term just a little bit differently. So this is going to be e x raised to the e minus 1. So it's a little deceptive, and we just want to be careful and mindful of that type of problem. And that's actually a good stopping point for this video. This is a video on Math 386, and we did 10 examples of finding the derivative. So, okay, thank you.